Question 5. Figure 14 shows some bumper cars. Bumper cars are designed to withstand collisions at low speed. Question 5.1. During a collision between a bumper car and the bumper car and the barrier act as a closed system. What is meant by a closed system? The total amount of energy of the bumper car and the barrier remained constant. In a closed system, the total energy always remains constant, or total momentum before collision of the bumper car and barrier equals total momentum after collision of the bumper car and the barrier. Question 5.2. How does Newton's third law of motion apply to the collision between the bumper car and the barrier? The force of the car on the barrier is equal to the force of the barrier on the car and in the opposite direction. Question 5.3. During the collision, the change in momentum of the bumper car is 700 kilograms meters per second. The time taken for the collision is 0.28 seconds. Calculate the force on the bumper car during the collision. The change in momentum is equal to force times time, which we call impulse. This is the change in momentum. F is force, T is time. Therefore, we can say F equals to change in momentum over time. Plug in the values, we get the force to be 2,500 newtons. Question 5.4. The bumper car has a flexible bumper. Explain how the flexible bumper reduces the risk of injury to the people in the bumper car during the collision. Increases the time taken for the collision to occur, so the rate of change of momentum decreases, reducing the force on the people because change in momentum is proportional to force. Question 5.5. A bumper car moved with an initial constant velocity and then accelerated at 2 meters per second squared. While accelerating, the bumper car traveled a distance of 1.5 meters. The final velocity of the bumper car was 2.5 meters per second. Calculate the initial constant velocity of the bumper car. Acceleration is 2 meters per second squared. Distance covered is 1.5 meters. Final velocity is 2.5 meters per second. Using v squared equals to u squared plus 2as. V is the final velocity, u is the initial velocity, a is the acceleration, s is the distance. Making u the subject, we get u equals to square root v squared minus 2as. Plugging in the values, we get u to be 0.5 meters per second. U is 0.50 meters per second.